Hi, and welcome to today's lesson on well installation. We only have one study guide for today, and it should be a fairly short lesson, and it's just to explain for a given area how you would install a well and make sure it's ready for sampling. So here are some images of wells that I've helped to install, some on backpackable drills, some on machine-mounted drills, some which are easy for us to kind of roll and deploy. Even this one over here, though, was still 500 pounds, so maybe not so easy to roll and deploy. But before you ever get started on even installing your wells, you have to understand what kind of well system you want to use. Now, if you're only interested in chemistry with depth, right, you might use what's called this multi-well system, where you have ports that are at these different depths, and you have what they call these orange things are packers that are in between them, and you're able to sample from these sampling ports. So therefore, you only drill one well, and you're good to go understanding and characterizing groundwater chemistry with depth. Conversely, if water levels are also really important to understand the hydrology in terms of the vertical and horizontal movement of water in terms of calculating the hydraulic gradient, then multiple boreholes will be needed to drill so that you can install multiple wells so that you can actually measure the water levels in those multi-level well systems. It's not possible here in these systems to be able to measure water levels, but in these nested wells, you are able to measure water levels themselves. All right, so there's a couple of considerations when installing a well. One, you have to be able to advance your borehole using a drilling device. The drill type that you use is going to be dependent upon the material you're drilling, and that you have to decide if you're going to be collecting material, whether that's unconsolidated or consolidated material like rock samples while you're doing it. And because of that, then you need to decide on the type of drill that you're going to use. So I don't need you to memorize all of the drill types, but to have an understanding of what is out there in terms of being able to drill wells themselves. And then finally, you have to know if your site has been contaminated, because that might depend on what kind of drilling fluids you use, and then also where you're going to put your drill material once you've drilled. In addition, there's this question of whether or not when drilling, you're going to enhance the amount of contamination at between different depths as well. So here are a couple of the types of drills that you might be working with. One is a rotary drill, and the second is a reverse rotary drill. The difference between these types of drills is just the direction of which water or drilling fluid or air, well, really drilling fluid, is forced. One is here that the fluid is forced around the sides of the drill and pushes the material and drill cuttings up to the surface, where conversely, the reverse rotary one circulates drilling fluids in a reverse direction. So for the rotary rig, we have drilling fluid is forced down the drill stem and out through the openings in the sides of the drill. This is more typical, where conversely the fluid here is going to be flushed on the outside of the drill and come back up through the inside of it itself. Typically we use either drilling muds, something like a bentonite, or water for being able to use for these types of drilling fluids. These can come in big or small. This is the same type of rig. Here we have water being connected to the bottom of it and water flowing out through the outside. This is kind of a general drill bit that you might see. You also have what are called air rotary. So instead of using a fluid, you're using compressed air at a very high pressure to move the material out of the way. This is oftentimes used for contaminated sites. And you have cable tool drilling, which is basically a hollow pipe being pounded into the ground. Here's two examples of areas where we've done this over and over and over again, and being removed and ever so slowly taking that material out of the way. We also have hollow stem ones, and now these hollow stem augers here actually are ones where we use for extracting material out of the bottom of them. They can have a plug, or you can remove that plug and put in what's called a split spoon to be able to actually collect the samples at the bottom of the auger stem. This is what a split spoon looks like. It's about arm's length and allows you to, it advances with the drill rig itself and allows you to be able to collect some of the sediments that are in those wells themselves, or the boreholes that you're creating. This gives you an idea of how that split spoon works, right? Either you could have a plug with a drill bit, so not collecting the material, or you can unplug that drill bit and put the split spoon down, and that split spoon, in advance of being disturbed with the cuttings, is pushed forward and is able to collect the material that you're looking for. Finally, in terms of drilling types, we have what's called handheld augers. Now, this is used when we know we're definitely going to be in loose material that's easy to cut through in terms of sediment. There are many different kinds of augers, and that's why I show you them all here. It's not important that you know exactly which one goes with what, but that you can see that there are vastly different configurations of augers that we can use for drilling into sediments. Now, typically, you're not going to go more than 10 meters of sediment with one of these before the pressure just becomes too hard for you to actually continue to remove material. Now, anytime that you're out drilling wells and drilling boreholes, you have to classify the material as it's coming out of the borehole so you know what your water is interacting with. And when possible, it's also nice to get and to take geophysical observations and measurements from the boreholes themselves so you can understand things like the distribution of fractures within the systems. And that helps you to understand the direction of water flow. And then finally, when you're done being able to install your wells, you have to clean them up, right? And clean up your drill equipment as well. Now, to install a well itself, right, it only occurs after you've actually dug and drilled your borehole. So once you have your borehole that's nice and clean, you can place a pipe, typically PVC, down the center of it. Sometimes it's also stainless steel, depending on what you're dealing with. And you put that down the center and then have a screen that comes at the bottom of it. Then it's going to be filled with material. So you pour sand around the well. Now that sand that you pour around the well is dependent upon the type of screening that you have. So you must match your material that goes around the well screen with the size of the well itself. And you can see some are really big. So around here you might not use sand, but instead a gravel pack. Now, the whole point of putting this sand or gravel pack that goes around these well screens is that they act to help clean the water themselves. So they keep the geologic material from the actual aquifer or from your area of interest from entering into the well. As I said before, the size of the slotted screen is dependent upon the type of geologic material that you're dealing with. But you want to be able to exclude at least 50 to 60% of the sediment in that area in order to actually draw clean water in. So once your well has been installed, right, you have your first primary filter pack. You'll then add a secondary filter pack onto it, which is a finer grained material. Then bentonite or cement, or a combination of the two, that goes up towards the land surface, finished by having a well pad that helps you to move water so water won't pool up at the top of it, and then you're going to cap it and put a guard around it as well. Once the well has been installed and the cement has had time to settle, you have to develop a well. Developing a well just means that you're going to surge water in and out of the screen to remove any fines in the vicinity of that well. The surging usually involves a long plunger and raising it up and down to force water in and out of the system. This is followed then by pumping any of the water in the fines out and then rinsing and repeating and doing over again. This can take anywhere from several hours to several days, depending on the amount of silty material that persists in your geologic formation. A well is only considered fully developed when clean water is drawn from that well. So with that, you now have an idea of how to go out and install a well. All right. Thank you.